In this video, we'll go through some examples of simplifying expressions involving fractions using order of operations and exponent rules. In this first example, we have 3 over 11 squared multiplied by 22 over 21 squared. There are several ways we could approach this, but what I'm going to do first is use the fact that they're both squared to combine the two exponents. So we'll have 3 over 11 multiplied by 22 over 21, and that entire quantity now will be squared. And now we'll follow order of operations. We'll look inside the parentheses first and see if we can simplify that product. Since we're multiplying two fractions together, we can write this as 3 times 22 over 11 times 21. We just multiply straight across the numerator and the denominator. Now we can start to simplify. 3 over 21 simplifies because those are both divisible by 3. We'll get 1 over 7. And then 22 over 11 simplifies. Those are both divisible by 11, so we'll get 2 over 1. In the numerator, this is going to leave us with 1 times 2, so this will be 2 divided by 1 times 7, so 7. And then all of this is still squared. Now we'll use our exponent rule to say that this is 2 squared over 7 squared, which we can simplify to 4 over 49. In this example, we're supposed to simplify this expression involving fractions. The first thing that we'll do, using order of operations, is we'll look for any parentheses or exponents. I don't see any of those, and so we'll move on to multiplication and division. So we'll have 7 times 2, I'm just multiplying straight across that first fraction, over 16 times 49. And then the second fraction we can combine as 7 times 3 over 24 times 28. I didn't multiply either of these out because I want to be able to simplify, and it's easier to see when it's already factored out what I need to do. The numerator and the denominator of the first fraction are both divisible by 7, so I could reduce them. Another thing that I see is that the numerator and denominator are both divisible by 2. I could divide the 2 by 2, and I can divide the 16 by 2. In the second fraction, I can reduce the 7 over 28 by dividing both of them by 7. I'll get 1 over 4. And then I can reduce the 3 over 24 by dividing both of those by 3. So I'll get 1 over 8. So now in the first fraction, I have 1 times 1 over 8 times 7, which gives me 56. So now I have 1 over 56. And in the second fraction, I have 1 times 1 divided by 8 times 4, which gives me 32. So my next step is going to be to compute the least common denominator. I could do this by factoring 56 and 32. 56 is going to be 8 times 7, and then 8 is 2 times 2 times 2, so I could write that as 2 cubed times 7. 32, on the other hand, is equal to 8 times 4. 8 is 2 cubed, and 4 is 2 squared, so I could write that as 2 to the 5th power. Then the least common denominator is going to be the least common multiple of these two values. We have the factors 2 and 7 showing up. The most that we see 2 showing up is to the 5th power, and the most that we see 7 showing up is to the 1st power. And so our least common denominator is going to be 2 to the 5th, or 32, times 7, which gives us 224. Now we can obtain a common denominator by multiplying each of these two fractions in the numerator and denominator by the value that gives us 224 in the denominator. So 1 over 56 is going to have to be multiplied by 4 over 4, because 4 times 56 gives us 224. And then 1 over 32 is going to have to be multiplied by 7 over 7. So when we multiply straight across, we'll get 4 over 224 plus 7 over 224. Now that we have the same denominators, we can add across the numerators, and so we'll have 11 over 224. The last thing that we need to do is just double check to see that 11 does not divide 224. It doesn't, and since 11 is prime, then this can't be reduced any further. In this example, we're told to simplify the expression, and we have a fraction where both the numerator and the denominator are expressions that need to be simplified. Whenever we see this situation, we want to think of there being parentheses around the numerator and the denominator. So we'll compute those first before we divide. We have 6 squared, which is 36, minus 9 squared, which is 81. And that's divided by -4 multiplied by 5 squared, which is 25. And now that we've computed all of the exponents, we can multiply 2 times 8, that's 16. In the numerator, we have 36 minus 81, which is -45, divided by -4 times 25 minus 16, which is 9. 45 and 9 are both divisible by 9. So in the numerator, when we divide by 9, we'll get -5, and in the denominator, when we divide by 9, this will be replaced with 1. So now we have -5 over -4 times 1. Now we have a negative divided by a negative, so that just becomes 5 over 4.